Good afternoon. Welcome. Thanks for joining my talk called Distributed Tracing as Architecture. I'm really glad to be back here past all of the Corona stuff we dealt with. So really thanks to Devox for organizing this. As it says on my first slide, this talk is aimed at engineers who are tired of enterprise architects, but also of engineers who are tired of maybe having junior developers that are just going to scream, you ain't gonna need it, when they don't understand certain things. I'm going to do my very best to put architecture back into the hands of developers, of engineers, and bring you a solution for these annoyances. My name is Bart Blommaerts. As you can hear from my accent, I live here in Belgium. I work here as well. I am a hands-on application architect. I own my own company called BB Consulting, which is a very original name. And I'm currently working for a large bank in Belgium. We're doing a blockchain-related project. It's not the orange sponsor of Devox, but it's the one with the blue logo, so I assume you will know what I'm talking about. If you're from Belgium, we're going to release in a couple of weeks. So really, if you see any references to blockchain from said bank, then I built that together with a couple of colleagues. If you want to contact me, you can always reach me via my Twitter handle. You can always reach me via the website as well. But I think that's really enough of an introduction, and I suggest we get started. Architecture. If you're here, I assume that you work as an architect, or at least care about architecture. Maybe raise your hand if you have the title of architect right now. About 20% of you. Raise your hand if you're doing architecture work. I really love to see that, about 70 to 60% of you. So I'm going to give a short introduction on application architecture. Don't worry, it's not going to be too long, and afterwards we're going to dive into technology, more precisely into distributed tracing. So what is architecture? The reason that we need architecture is because we are trying to create a system. We're trying to build something, because if we're not building anything, well, we don't need any architecture. When I talk about system, I talk about all of the components that together form one application, one use case, one business case. So it can be microservices, serverless, monolithic applications, whatever it can be, but it fulfills one business need. So just to make it very clear, I'm not talking about enterprise architecture. I'm not talking about the system of systems. That's really not the scope of this talk. And we create a system for stakeholders. Stakeholder, for example, can be your customers, the people who actually be using the system, but also for the people who will pay for the system. And obviously also for the developers who are going to create the system. So there are multiple stakeholders, and the goal of an architect is to be able to share your vision of the application, and it needs to be crystal clear so that all of your stakeholders understand it. So since there are different stakeholders, this also means iterating over certain parts of the architecture. Your business stakeholder is looking for different things than the developer who's creating things. And you need to make sure that when you communicate your vision, that you also make sure that you get buy-in from all of these stakeholders. And every system has an architecture. It might not be a formal one, it might not be a good one, but every system has an architecture. Even if you have a big pile of spaghetti code, there is some kind of architecture in there. I hope that we're trying to do better, but there is architecture in there as well. It's not what we're striving for. And the architectural is typically described in architectural description. And this architectural description documents the architecture for its stakeholders. So it documents this for the customers, for the users, for the people who are paying for it, for developers, but also for other maybe parts of the organization, like your enterprise architect that wants to get some information on your architecture. Why is it there? It is there to make your architectural decisions explicit. I'm going to talk about architecture decisions a couple of times. It's a very important concept. Architecture really is about making decisions. So the goal of the architectural description is to document the architecture for the stakeholders so that you can document, predict how the system is going to behave, how it's going to behave on inception, but also in the future down the line. Now, how do we do this? there's an ISO standard that says you need to use views for this. And there are multiple templates or architectural styles that you can use for this. There's one called C4 by Simon Brown, who has a talk here at Devox, I think, tomorrow or this evening. So if you want to learn more about his model, definitely check it out. Another one that's very famous is from Kruchten. It's a bit older, but it's still used in many places. There's Viewpoints and Perspectives by Ion Woods and Nick Rosansky. I'm not here to convince you that one is better than the other. There are multiple. Just basically pick one that works for you, and then be consistent. Try to make it sure that your views, your perspectives, what you're doing is clear. Now, what do you put in these kind of views? You describe what is architecturally significant. Means it's worth taking your time, it's worth writing down. When is it worth writing down? Well, when the system cannot be successful without them. Or when your stakeholders say, look, this is very important for me. For example, if you are working for management, maybe they need to report it to C-level management, so you need to make sure that you can help them as good as possible. And deciding what to put in these views means making decisions. Again, very important. And last but not least, these views, they are shaped by perspectives. In perspectives are often also called quality attributes or non-functional requirements. I'm not a really big fan of the term non-functional requirements because oftentimes these non-functional requirements, they are very functional in need. Let me give you a very easy example. If your system has poor scalability and your users cannot use it, that's pretty functional to me, I think. If you want to register tickets for an event and the event website crashes, the scalability has caused really functional issues. These perspectives are actually the most important part of your job as a software architect, because being an architect means that you need to make trade-offs between these perspectives. So, for example, the security perspective can potentially hinder the performance perspective. We all know that every website that we use should use HTTPS, but HTTPS is actually a lot slower than HTTP. So there the choice is easy, but sometimes it becomes more difficult. For example, if you want to use multi-factor authentication, then it has impact on the user experience. Especially less technical people will find it very cumbersome that they need multi-factor authentication. So it's very important as an architect that you look at the pros and the cons and that you make the correct trade-off for your architecture. All right, that's it for this one. Now that we have established what architecture is, it's very important that we also talk how are we going to do this? And I'm trying to give you an answer for that in the next few slides. So how do we create it? And you will see that this part really ties in nicely with the next part about distributed tracing. So there are a couple of approaches possible, and I'll try to get some feedback from you guys as well. So the first one is called BDUF, or Big Design Upfront. Big Design Upfront is actually what's happening when architects take themselves too seriously. You start creating the architecture before any of the implementation has started, before you have a development team. You start looking at all possible use cases, at all possible unhappy paths, future evolution, and you know that evolution might never come. You can be wrong at the very beginning. Big design upfront is also part of the reason why a lot of developers really don't like architects, or really think, okay, this person is going to tell me exactly what I need to do, but hasn't touched a letter of code in 20 years. So big design upfront can be useful. For example, when you're trying to send rockets to the moon, then you probably want to think about all of the possible scenarios. But on the other hand, if you look at SpaceX, they're actually sending rockets to the moon, and they do it iteratively as well. It doesn't always work, but we also noticed that by having feedback cycles, that they're actually a lot quicker than what NASA is doing. Okay. Okay, then it's obvious, right? Maybe let me go back to the previous one. Big design upfront. Who is doing a project right now where there is a big design upfront, everything is crystal clear, and you just need to follow those guidelines? A couple of you. Do you like it? You need to scream because I can't hear you down here. Is it working for you? Is it okay? Not working for you. Nodding that it's not working for you. Okay, then we go on to the next one. No design upfront. NDUF. That's probably like a good antidote to big design upfront. But no design upfront is typically also not the best idea. it means that there's some functional requirements and you just start writing codes. The developers pick up their MacBooks or whatever that they're using, and they start typing codes, and they don't think about things like deployment or evolution or security. Really, this is in my opinion, a recipe for disaster. Because it's also a good reason if you want to rewrite your code base every so often. And this is actually still happening quite frequently, especially in the entire startup scene or startup world, because people want to get out new features as soon as possible. They don't want to think about the problem, they want to solve the problem first. And you frequently hear that when startups grow, they start becoming Java companies. Maybe they should have taken a little bit of time to think about the issue at hand first. And then finally, just enough design upfront. Now, there are cases where big design upfront is useful, where it's needed. For example, sending rockets to the moon. There are cases where no design upfront can be useful as well. Maybe you're trying to do some proof of concept or trying to test something or try something before you go to the real application. So prototyping entirely new stuff. So it has its value, but a lot of the time, what we really need is just enough design upfront. But this is a really vague statement. It's also very difficult to get right. I mean, what is just enough design? Can anybody tell me what just enough is? Or when is just enough design? Who is just enough design? It's really difficult. It's a vague term. And I'm going to try to give you an answer to that question. Now, before we go on, who's currently working on a project where there's zero design upfront? No design upfront. Nobody. Is anybody working for startup? There are people, and you have design up front. Some of it. So just enough, maybe. All right, all right.
Sometimes it's not enough, but always better to have at least some.
I agree. So sometimes it's not enough, but it's always better to have something. So I agree, and it's also something that you often see when looking at startups, because their time to market is everything they need to really quickly. Now, one way that I think that you can achieve just enough design up front is called OODA. OODA means observe, orient, decide, act. OODA actually is a term that was coined by a United States fighter pilot called John Boyd, who was in the war in his fighter jet, and he was looking continuously, observing around him, looking through the windows of his fighter plane, looking, okay, what's happening? How can I use my experience, the things that I'm seeing, to orient about this? Do I need to dive away from the attacking plane? Do I need to go back it? Do I need to shoot it? Those kind of things. And then you need to make a decision, a conscious decision. Okay, this is what I'm going to do, and then act upon it. Now, I don't think that most of us are fighter pilots, but it actually works for software as well. Because as an architect, we make models. And models, they introduce abstraction, but they also remove a lot of the noise. So in the world that we are living in and the project that we are doing, we really need to observe the circumstances then in which we are building our application. So there can be external circumstances, internal circumstances, but we need to make sure that we try to make sense of them. So for example, what does our customer want? How does our system going to interact with other systems? And we need to get these observations in order that we can do the orientation phase and really say, okay, what am I going to do about this observation that I just made? How am I going to use my experience, the things that I've learned in the past, the things that I can talk with my colleagues about, and then really come up to the decision plan. I mentioned that architects is about making decisions. We're going to have to decide on a response. And then finally, we're actually going to act on that decision. We're going to do it. And we need to do this often and frequently because we want to gain advantage. Now, as you can see on the drawing, this is not a linear process. It benefits from continuous feedback cycles. Feedback loops mean that when you observe something that you may write to a view, that it can have impact on a view that already exists. When you make a certain decision, it's possible that your observations will no longer be valid. So since this is a reentrant loop, we need to make sure that going through all of the stages is not something that takes a lot of time. It does not need to be formal. You don't need to have like a list saying observations and starting writing everything down. It's like a mental model that you need to have in your head and to use to create your architect description. There are variants on OODA like PDCA, but OODA typically is also what I like to use, what works for me, and I'm also going to refer to it back in the next slides. All right, enough talk about architecture. Let's start looking at distributed tracing. What is distributed tracing? If you look on Wikipedia, it says distributed tracing is a method of observing requests as they propagate through distributed cloud environments. What does this mean? In modern software environments, we typically use microservices, serverless, maybe event-driven systems, and we deploy these to the cloud. It can be a public cloud, maybe on-premise cloud, and we also often are going to integrate this with existing systems, maybe with your on-premise data center that you still have, maybe with a SaaS that's out there, maybe you have an IT environment that sends information to you, and you need to integrate with that. So when you have one request to your service, it will often call other services in order to do its job. And this kind of request, they're going to span multiple services. Each of these services do something with the request. So for example, writing it to the database, publishing it to a messaging system, maybe some calculations, doing your business logic, whatever your application needs to do, and then it will pass the response to the next message in line. And distributed tracing helps to understand the behavior of your application, and it will also be very useful to troubleshoot problems. So this is an example from Jaeger, which is actually on their website as well. And this is a typical trace from distributed tracing. So in the column on the left, below service and orientation, you can see the different traces. So you see, for example, that the order service uses the user's service, but in parallel, it also uses the stock service, and it does something with the information in these different services. And then on the column on the right, you can see the spans. And a span represents an action. So an HTTP request, a database call, those kind of things. And then on the x-axis, you can see the distribution of these spans over time. So we know exactly what is being done when and how long it will take. When you start looking at debugging, you can immediately say if one of the calls takes a lot of time, then you probably want to focus on that specific call. There is a session also, I think tomorrow, about debugging distributed systems. So I definitely am going to go there myself, because this really is a useful tool when you want to debug these kind of systems. And most distributed tracing tools have a user interface that's very similar to this one. I'm going to use AWS XRay myself with a demo later, but this is not a promotional talk for AWS. You can basically achieve the exact same thing with other tools that are available on the market right now. So in summary, traces on the left, spans on the right, and on the x-axis we have the timeline. So a collection of tools. I'm not going to detail in all of these, but on the right column you see a bunch of popular instrumentation tools like Brave, Finagle. And on the left-hand side you can see services that they integrate with. I think Zipkin is probably the most famous one right now. If you're interested in standards and in how these things are evolving, definitely check out the Open Telemetry website. There's a talk tomorrow morning from Philip on Open Telemetry, if you want to see how things are evolving. Just as a recap, there are many tools. I think that basically every application platform monitoring tool supports tracing. So any APM tool supports distributed tracing. Now, it's important to know why you're selecting a tool, because some of these tools are open source. They're free to use, or they're free to use if you're on the specific cloud vendor. Other tools that are in the list can be very expensive, like Dynatrace. It's not the cheapest tool out there. So just really make sure what you're trying to do with the tool, and make a conscious decision. So on the one hand, we have viewpoints and perspectives. We have our architectural design that we're trying to create. We think about the system. We try to make sure, okay, this is what it wants to do. I use OODA to make the correct observations and decisions. And on the other hand, we have the runtime observations. How is my system behaving at runtime? So we're going to try to bridge these. We're going to bring them together. And the easiest way to do this is with a use case. So this really is a dummy use case. Don't take it too seriously. It's just to explain the next slides. So we have a customer who inputs data into the system, so via a user interface, mobile application, an API, whatever. And this data is persisted. So basically, those two first steps are in any information system that exists. Then we're going to publish the data to interested parties. So the customer enters something, the system decides, oh, this is an interesting event. I want to publish this to the outside world and inform other consumers about this. And then one of these other consumers is going to read the published data and then write it to a file. Again, it's a dummy use case. You probably don't need a lot of just enough design up front for this, but still, it's the easiest thing that I could come up with to explain the next steps. So, customer inputs data into the system. Customer, system, done. Very simple. Now, very important, and I'll say this only once, you don't need formal modeling language. You don't need UML or Archi or Enterprise Architect or whatever. If you're doing just enough design, it is important that you add a legend to the diagram that you're creating. This gray rectangle, well, if I don't add a legend to it, then people might not understand what it is. So add a legend and be consistent in this legend. I didn't do it for the demo, but I really wanted to explain it. The goal of architecture is to make sure that your stakeholders understand what you're trying to say. Believe me, not a lot of business folks really understand UML. Honestly, not a lot of developers understand UML either. So you just need to make sure that you can convey the message to these people, to your stakeholders. And then step 2, the data is persisted to a database. Done. So really, this is just enough design up fronting. It's really easy. It's two nice drawings on a diagram, so yeah, it shouldn't be too difficult for anyone, I think. And then we are going to publish this data to an interested party. So it says publishing, okay, I need to think about this. There's maybe some kind of event generated from my user action. So I think I'm going to use some kind of messaging system. I'm going to put it on a queue. I don't know which messaging system. I don't know anything about the messaging topology. Is this going to be pub-sub? Is this going to peer-to-peer? I don't know, and at this moment in time, I also don't really care. I just know I need to be able to give the event information to interested parties. And maybe we can come up with all of the messaging details later, or we can do it together with our development team. And then last but not least, another party, so in this case, system 2, is going to consume the published data and to write it to a file. So this can potentially be just enough. Now we can make some software, but it's important, as always, we like short feedback loops and short iterations. This morning during the keynote, Venkat was also really stressing the agile nature of having short feedback loops, short iterations. And then after the next few slides, hi drone, we're going to look at the real thing. So for the demo, I'm going to use AWS, and I'm going to use Kubernetes on AWS, so Elastic Kubernetes system, using XRay as well. Like I said before, this is not a pitch to use AWS. It's just any system that can use it. All of the distributed tracing tools really can help you. And what you will notice typically in architecture is that costly decisions, strategic decisions, they're often taken by the customer, and we just need to need to work with them. Why? Because these are like really overarching concerns, like hosting, for example. This is a multi-year decision because it's an expensive decision. We're going to use Kubernetes because, well, Kubernetes is still all the hype. So imagine that our customer has chosen this for us. Same as the cloud vendor, we're going to use AWS, but this typically is also a given. We're going to use Java 17 using Spring Boot on Elastic Kubernetes Service. Now, important when you work for a smaller customer or on a greenfield project or maybe a small project or a pet project, I believe making a sound hosting decision is something that you need to do upfront. Because a lot of your architecture will be dependent on your hosting environment. If you're going to run it on Heroku or on AWS or on-premise, it's going to be different. The easiest reason to think about this is there are different services available on AWS than, for example, on-premise. If you have a private cloud on-premise, you may not have a messaging system available, or you might not have something like Kafka or Kinesis if you want to have that kind of infrastructure. So it's important that you think about hosting upfront and you make a good decision. When you have the opportunity to do this, it's also important that you not only look at the technical things. You need to look at costs. You need to look at legal issues, for example, GDPR. You need to look at the evolution of your system, but also of your hosting. You need to look at available services, because a lot of the cloud vendors, they really try to differentiate themselves amongst their competitors by really creating new services and making them available faster than their competitors can use them. So really important that you think about this thoroughly. And this basically goes for all decisions that are difficult to change later. So that's an important one. Okay, so the customer is going to input data on the system. So we create a Spring Boot application. For the demo, it's called Hello DevOps. And we are going to integrate it with AWS XRay. AWS XRay is a Java SDK that you can use. They have SDKs obviously available for all popular programming languages. And in Java, it works with aspect-oriented programming, so they have point cuts, and you can say, okay, I want to instrument these calls within my application. Typically, this is done on the endpoint level, so on the what's it called again? On the REST interface, because then it will automatically trace all of the steps downward as well. This view is in AWS CloudWatch. CloudWatch is a part of AWS where you can see all of your logging, all of your metrics, so it really makes a lot of sense to look for your distributed tracing there as well. Now, when we are implementing the Hello DevOps application, we realized, okay, I probably don't want to expose Kubernetes to the outside world, because that would be like a security issue. So we've decided to put an API gateway in front of it. So the API gateway dev stage. This could be an application load balancer as well, but for the demo, it's the API gateway. And we made that decision because this also offers us a lot of functionalities. For example, we can have DDoS protection, we can have rate limiting, thresholds, security authentication, those kind of things. They are all available out of the box. So even though that we've just started with our application, we already deviated from the just enough design up front by doing this. Now, when you've created this, you can think, okay, I'm going to go back to the design phase, back to just enough design up front, and I need to change it because, yeah, obviously I missed something. Kind of depends on what you're trying to achieve. If it's a very small change, I think it's better to continue working on it. But if you want to inform your co-developers or other stakeholders, maybe you want to update the architectural description as well. Next step is we're going to persist the data. So for the example, there is no formal data model, so I just put everything in a NoSQL DynamoDB. It is called Greeter. And as you can imagine, XRay integrates very nicely with DynamoDB or with other AWS services. What's really interesting about this is I did not have to write any code for this. I just did the DynamoDB enhanced SDK. I write my code to put the item into the table, and I add a dependency to my project called SDK Instrumenter, and the SDK takes care of everything. So really, I get this diagram entirely for free. I don't need to do anything for it. So I think that's really useful. Now, again, observing this, we use our experience, we start orienting again, and we think, well, if we want to have a user writing data to my database, I probably need some form of authentication. So we make this orientation and we make the decision, okay, we're going to add the authentication and then act on it. So remember OODA from earlier, so we have changed it. And we are going to use authorizers. So the AWS API gateway integrates with AWS Lambda to get authorizers. We have created one in JavaScript. Also, if you want any of the source code, everything is available on GitHub. It's very simple, but I'll share the links anyway. So in Lambda, we enable X-ray tracing, and again, this comes for free out of the box. I didn't need to write any instrumentation code. So free lunch really exists, and not only on DevOps, but when doing architecture as well. Now, again, we might want to share this with colleagues, because, okay, we have deviated from the initial design twice now. We hardly wrote any code, but we have deviated already twice. So maybe we want to talk to stakeholders again and show them, okay, this is what we're doing. We can talk about it, we can reiterate, learn more from them. For the demo, I didn't do this. but you can see that there are different possibilities possible. So we are not only developing it in an agile manner, we're also doing the architecture in an agile manner. And then the data from the greeter table is persisted in a messaging system. AWS has a lot of messaging systems like SNS, SQS, Kinesis, Event Bridge, etc., etc. This is just a very simple use case, so I'm just going to publish it to SNS, and surprise, surprise, XRay integrates with that also very nicely. I didn't write any code for this. This just comes for free out of the box. And then the last one, there is another customer, in this case called BDUF, and it's going to consume the messaging system and write it to a file on S3. Now, in the real world, this BDUF container would probably not live in the same Kubernetes cluster than my application. Maybe it lives in a different cluster, maybe it's an external company. All of that is possible. For the demo, I kept it easy and put it in there. But you need to be aware that when you're using XRay, you don't need to live on AWS. So it's perfectly possible to run the XRay daemon on your local machine, on-premise, on another cloud vendor, and it will send that information to XRay, the server, and you still get these graphs. Also makes it very easy to write code without doing any actual deployments, because it will just work on your laptop as well. And if you look at the output of the XRay daemon, you will also get a lot of information on what exactly is being sent to them. So you will see the traces, which XRay calls segments. The segments and subsegments are also going to be visible over there. Now, what is really interesting about this is, well, first of all, the architecture was basically generated from the code. I didn't need to do anything for it, just add a couple of dependencies and configure it in AWS. And it is data. So if you compare the previous slide with this slide, you see that there's a lot of more information available. This one, for example, has latency information. I'll show a couple of others live later today. But you also see all of the green circles. This is actually the response of your system. If it's successful, everything is green. So obviously, for the demo, everything needs to be green. But if there are client-side errors, then parts of your circles will be orange. And if there are server-side errors, then they're going to be red. So you immediately know if one of the components is misbehaving, and you can drill down on it and look at the traces. So this is very similar to the trace from Jaeger that I showed earlier. This is actually one call in the running system, where you see on the left-hand side, you see the traces. On the right-hand side, you see the spans, and you see the timescale. So if one of my invocations is really slow, then in here I can immediately say which one it is. Just by looking at this, we see, for example, that the BDUF application is a lot slower than the Hello DevOps application. So this can be really useful when debugging. Okay, what's next is we're going to look at it for real. I hope that I'm still logged in, because otherwise, I'm not logged in. So, but I'm going to execute the call first. So I added this curl script. Let's add something. Hello DevOps. This is room 6, I think. We're just going to copy paste it. It's a simple demo use case. And then we're going to execute it, and then we'll hope for the best. Probably need to press enter. And, well, something happened. So let's look at our browser, if I can find it. There we go. Let's look at DynamoDB first. We go to our table that we created called Greeter. We're going to explore it. And you can see, hello DevOps, this is room 6. So at least something was working. Earlier I said that the traces are available in CloudWatch. So let's have a quick look. The XRay traces are in here. We'll start with the traces, and we'll go to the service map from there. So we just scroll down where you can see my trace. It is 44 seconds old, so that's probably the one that we're looking for. And in here, I'm going to shrink it a little bit. You can see the exact same thing as I was showing earlier. So it is working. If you scroll down, or if you click on one of the nodes, you get a lot of more information. If there are, for example, stack traces and you expose them, then the stack traces will be visible here as well. And you can also just look at the segment timeline. If I can find it. It's difficult to look like this. Here you go. So here you can see all of the different requests that I've done and everything that's gone on in the system. There is also another service within AWS called XRay. Because it's really interesting, everything is data. It's generated from the application at runtime. And since it's data, we can also use it for other purposes as well, like debugging or like looking at the system. If the service map wants to show up. Here you can see, for example, that right now it's showing the icons of the services that I'm using. We can click on this one and we see the response times. If you have a lot of requests, you can also resize the nodes. If, for example, you notice that a lot of requests are coming into the API gateway and then something is going wrong, then the API gateway node is going to be a lot bigger than the other nodes because the requests don't end up there. So that's really cool. You also have this analytics tab where you can filter on your requests, saying, okay, I only want requests that have failed HTTP codes, so 4xx or 5xx. You can work on user agents. You can, well, really use it. I hope this is visible. You can, for example, sort on the things. I only want to see the responses that were slower than 1 second, because it actually took quite some time for something very small. You get all of this just for free. Okay. So, what's next? As any architect will tell you, it depends. And it depends on what you're trying to do. If your system is finished, you want to put it to production and forget about it, then you can do just what I did. Just copy paste a couple of the traces of the service map view that you had, put it in a document, and you're done. But it might also be that you know, okay, the customer is going to evolve this system. Maybe the customer wants to add new functionality to the system, and then it's difficult if you need to change your diagram based on screenshots. So you might say, okay, I'm going to go back to the just enough design up front part, and I'm going to create a better design because it's easier for me to change and to really visualize things before starting any code, before writing any code. Because maybe you want to use your design and talk about it with peers. Okay, what do you guys or girls think about this? Are we going this route? It's a lot easier if you can do that via a simple diagram that doesn't take a lot of time versus when you also already need to write the code. So, as a quick end to the presentation, this could be the final result in your architect description. It's based on XRay as a source, so it's really easy to create. And this view can actually be used for other things as well. If you add VPC information to this diagram, then maybe you can create a deployment view if you want to look at stakeholders that are primarily interested in the deployment of the thing. If you add a functional description, for example, to Hello DevOps or to different components, you can say, this is what these components are doing. This is what they're responsible for, and you can create a functional view for it, maybe share it with function analysts if you have those in your team. So all of those things are possible, and it was really easy to create because we have a runtime view of it as well. And that is it. I have 2 minutes left. So again, if you want to contact me via Twitter, this is my Twitter handle. The source code is available on those links. Small disclaimer, the source code was created to present the demo on DevOps. Do not use this in an actual project. There are 0 unit tests, so it's probably not a good idea, but you maybe can get some inspiration from that. And with that said, thank you very much for your time. And if you have any questions, by all means,